Hey everybody, this is the second part of the multi-factor ANOVA. So this is the third ANOVA of all of the ANOVAs that we're going to talk about in this particular class. So just want to recap what we're talking about. The example that we're working with is a study that is examining two independent variables and how these independent variables affect a single dependent variable. So multi-factor ANOVAs can take many different shapes, and when I say multi-factor, what I'm simply referring to is the idea that it's an analysis of variance that can analyze multiple independent variables or multiple factors at the same time and how they affect a dependent variable. So in this chapter, the most that we're going to look at is the impact of two independent variables on a dependent variable, which is why this chapter is aptly titled Two-Way ANOVA. So the two-way analysis of variance we are going to perform is one that examines the impact of these two independent variables. Anxiety, and anxiety has two levels, high and low, and the other independent variable is instruction, and the instruction is either teaching in class or being taught online. So as you can see here, we have individuals who have been categorized as having high or low math anxiety, and then those individuals are then either taught statistics or math, whatever it is, in a classroom, or they're taught online. So we can already start to think about the impact of each independent variable individually on their ability to learn statistics or learn math. And we can also think about the combined effect of these two independent variables on their impact to learn. So let's look at each independent variable. Let's think about its effect independently, if you will. So if you're a person who has a lot of anxiety over math, how do you think that's going to impact your ability to learn? The research does show that if you have a lot of anxiety, it can impair your ability to learn. Whether it's psychological or not, it just has this impact, right? So people who have math anxiety already have this hurdle, they have to jump over. The other thing is classroom instruction. The way that a person learns can be influenced on how the person is presented the information. Me personally, I would prefer to be in a classroom setting, have the interaction with my instructor, and learn that way. In an online environment, you don't have that as much. You're provided the information, and I think you have to be more of, I don't want to say active, but you have to be more self-motivated and really seek that information out and work a little harder to teach yourself. So I think online instruction is more challenging. So that can definitely affect your learning. But now if you combine these two together, so let's say you have high math anxiety and you're in an online environment, I would think that those two factors combine to actually create some synergistic effect. So I would hypothesize that if an individual is in a really high anxiety situation about math, and all of a sudden they're faced in an online environment, that their ability to learn could really be hindered. So that's what this study is all about, and that's what the multi-factor ANOVA is doing. It's going to help us understand relatively the contribution of anxiety alone on learning. It's going to help us understand relatively the contribution of classroom instruction alone on learning, and then it's also going to look at that interaction. Okay, that's what the multi-factor ANOVA does. And because of that, this multi-factor design is really more lifelike, because if we think about how research is trying to understand behavior, human behavior, and how we respond, our ability to learn is impacted by a variety of things. Anxiety is one factor, classroom instruction is another. If we look at these independently, they give us a little bit of the picture, but if you put them together, they really give us a more accurate reflection of what's really going on. So that's one of the big advantages of this multi-factor ANOVA. It helps us examine more realistic types of studies. Yeah. The last thing I want to do before we go on and get into the details of this analysis and go through the 6 steps of hypothesis testing is the simplicity of this design and how quickly this design can get very complicated. So in this design, we're looking at 2 independent variables, right? Anxiety and classroom instruction. And for each of these independent variables, we have 2 levels. So anxiety is divided into a high and low condition, and classroom instruction, or excuse me, and instruction is divided into a classroom and online condition. All right, so when I refer to this type of design, if I were to refer to it to somebody in shorthand, I would call this a 2x2 design. So let me tell you what that means. The number of numbers I state indicates how many independent variables there are in this design. So if I say there's a 2x2, I've just said 2 by 2. So I've just said 2 numbers. That tells you there's 2 independent variables, right? Now the value assigned indicates how many levels of that independent variable there are. So when there's a 2x2, it tells you that for that first independent variable, there are 2 levels, so high and low. And for that second independent variable, there's also 2 levels, classroom and online. If I wanted to add maybe a 3rd level here, so this is fully face-to-face, this is fully online. What if I wanted to look at a hybrid model? I could add this 3rd level. Well, in that case, my design would still have 2 independent variables, but instead of referring to it as a 2x2, I would now refer to it as a 2x3 because I would add that hybrid right there, okay? So 2x3, I still have 2 numbers, so it tells me there's 2 independent variables, but the number assigned to each number just indicates how many levels there are. Now, this is where it kind of indicates how sophisticated and how complex designs can get. Here in this design, we have a 2x2. 2 times 2 equals 4, right? Well, look, we have 1, 2, 3, 4 treatment conditions. High math, fully crossed with classroom instruction. High math, fully crossed with online. Low math with classroom, low math, online. So we have 4 groups. If we were to create this into a 2x3, we would have 2 times 3 is 6 treatment condition. We'd have to have high math with classroom, online, and then a 3rd hybrid, and low math with classroom, online, and a hybrid. Why is this important? Well, when you're designing a study, we have to keep in mind our subject pool and the feasibility of getting participants to volunteer. So just by adding another level of that independent variable, now we have 2 more treatment conditions. So think about if we added another level here, we'd all of a sudden go from a 2x3 to now a 3x3, and that means we have 9 treatment conditions. So this could get exponentially greater. So hopefully that makes sense, kind of understanding the lingo around with this. And what these numbers mean. So again, if you've got any questions, let me know. Email me at asikorsky@tamit.edu. Y'all take care. Bye-bye.